Hello and welcome to this episode of Math with Martinez. We are in our pre-cal unit on vectors and we are looking at component form today. So let's begin by defining what exactly does it mean if we're talking about a vector in standard position. Well, a vector in standard position is when the initial point of the vector is at the origin, like you see in this illustration. So let's pause and write that down. So when you have a vector in standard position and its terminal point is, like you can see highlighted here, let me highlight it for you. Here's that terminal point A, B. Then we can write our vector in what is called component form, and that would be to write it like this. To write that V, that vector is, and then inside these little like unique brackets, these vector brackets, A, B, just like that. Now the magnitude and the direction of this angle, now that's an angle in standard position, right? The magnitude and the direction of that angle is given in component, when it's given in component form, can be found using the following formulas. So its magnitude, the magnitude of that vector in standard position is going to be the square root of a squared plus b squared, where, remember, what we're saying here is, if you think about it in terms of trigonometry, your a is that horizontal distance and b is the vertical distance of this reference triangle that is drawn in your coordinate plane. And so really what you're finding here, the magnitude, is the hypotenuse. So it's not a really big surprise. It is really just an application of the Pythagorean theorem from our right triangle trigonometry. And the angle, well, your angle is going to be relating these two sides, which would mean the opposite side from your angle and the adjacent side. Which trig ratio relates opposite and adjacent? That is tangent. So your angle is going to be the opposite, which would be your b, your y value, over your a, which is that x value. And then if you were finding theta, if you were solving for theta, then you take inverse tangent of that ratio, like we have done in our prior units. And we're going to do that now. We're going to find the magnitude and the direction angle for each vector here in these examples. So let's go ahead and begin. If we're going to find our magnitude, it is found by taking the absolute value of, it is written, this notation, it looks like a double absolute value. And then we take the square root of our two components, A and B. So that's 7 squared and 24 squared. We're really taking the square root of, what value is that? 625, which is equal to 25. It is a perfect square. And if we're going to find the direction angle for this vector, thinking again of it like illustrated in your coordinate plane, what would be the amount of rotation there, that direction angle from that initial side? Well, it's going to be tangent of that angle would be your y value or your b value, which is the 24 over 7. You would need to take inverse tangent of that. And what is that value? When you grab your handy dandy calculator, let's go ahead and do one together so you can see. Let's grab that. make sure that you are in degrees. Check your settings, make sure that you're in degrees. Good, I'm in degrees. So here we go. We're going to do inverse tangent of that ratio, which was 24/7. And in degrees, that would be, we'll go ahead and round it. It would be that our angle is 73.74 degrees. So there's the magnitude and the direction for this vector. Let's do the one directly below it. Let's do example number 3 here. If we're going to find the magnitude of this vector, it's going to be found by taking the square root of the two components. Make sure that when you do this, it's 8 squared, and then that -12, both parts there, the value and the sign need to be in parentheses. Otherwise, you will not be squaring a negative, and the value will end up being very different. When you take that expression and type it in your calculator, you're going to have the square root of 208, which if we go ahead and do that as a decimal approximation, that's going to be 14.42, which you'll see right here. If I go ahead and take, if I take the square root of 208, 14.42 as a decimal approximation. It's not exact because it has been rounded. Then to find our angle, it is your B value, which you may want to label this A and B. It's the B value over your A value, which, is 8. So that means that our theta is going to be, watch what happens here. Let's go ahead and grab our calculator. Excuse me, sorry. All right, now what exactly does that mean? What is this unique value that we're getting? Can you guys tell me what I did wrong here? That doesn't seem to make sense, that I'd get a negative angle. What did I do wrong? Can you catch my mistake? Yeah, make sure that you recall that what we're doing here is we're actually taking the inverse tangent of that -12/8. So when you take that inverse tangent of the fraction, -12/8, you'll get, why isn't it pulling up? There we go. -53.31. -56.31 degrees, which we are going to want to convert that into a positive rotation. So what would be the coterminal angle? So instead of going down that amount, if we were to rotate positively, how much would that be? That would be to take the difference of 360 and that value. Oops. I did negative instead of minus. Let me do that again. Minus. Oh my goodness, my calculator is giving me so many troubles. 360 minus my 56.31, and that gives me 303.69 degrees. So let's go ahead and write that in here. I'm going to scoot this over and write my positive final answer, 303.69 degrees. All right, now last one. Why don't you guys try this one on your own? What would be the magnitude for vector g? Pause the video and try that one on your own. Yeah, so if you take the magnitude, that is to take the square root of the -8 and the -2, their values squared, summed together. That's the square root of 68, which as a simplified fraction would actually be, you can take 4 and 17, so that's 2 square root of 17. And that is approximately 8.25. And to find the value for your angle, you'd set it up as tangent because that's what equates the opposite and adjacent sides. Tangent of your B over your A. So this is really that we're taking, theta is going to be that inverse tangent. I can write this down below. Of that -8 over -2. Make sure that you choose inverse tangent. -8. And you'll get your tangent angle. Now, be aware of which quadrant this is in and that this does make sense. If we were in, which quadrant would we be in to have these two components, -2 and -8? It would have to be down here. So does it make sense, if that's your terminal point, that I've only gone 75 degrees? No, that does not make sense. What must we have here? This must actually be your reference angle. So what that means is I've actually gone 75 degrees beyond right here. So this angle right here is what is that 75. That theta is what is 75.96 degrees. And so if I want to know the entire rotation, what are we going to have to do? We're going to have to add the part that was missing to that, which would be to add 180 degrees to it. All right, so that gives us right here, what we have is 75.96 degrees. But in order to find the total, we've got to take that and add 180, and that gives us 255.96. There we go. All right, so those are several examples where we are finding the magnitude and direction for a vector in standard position. But what do we do if your vector is not in standard position? How do we write component form for any vector? Well, if you've got your 2 points, your initial point and your terminal point, then to write your vector in component form, you're just going to take the difference of the x values, and that'll be your A, and then the difference of your y components, and that will be your B. So here, if we were going to write the vector CD in component form, then that would be to take the difference of your x's and the difference of your y's. That means that we would take 6 minus 3, that would be the A value, and then 5 minus 2, which is going to simplify to, I'm sorry, I had this backwards. You've always got to do your second. 3 minus 5. There we go. You've always got to do your twos, your second value minus your first, your terminal minus your initial. And then that gives us 3. Make sure this looks nice and pointed. 3, -2. There you go. Now you guys try example number 8. Can you write the component form for vector RS? All right, well, it would be the difference of your x values. So I always label them -2 minus 5. And then the difference of your y's, second one first, 1 minus 10. That's going to be -7, -9. So there you all go. We now know how to find the magnitude and direction when our vector is in standard form, and we know how to take any of our vectors and write it in component form, which would allow us, once it's written in component form, to find magnitude and the direction angle. Be really aware here, like we saw in example 3 and example 5, that if what you have is an angle, when you do the inverse tangent, if your angle is negative, then you're going to have to subtract that so that you find the correct value based on where your terminal point is. And if you get something that seems a little bit lacking based on where you are, then that is it. Once again, it's the reference angle. And so what you've got to do is, like we saw often in our prior units, you're going to have to use a bit of reasoning here to identify, okay, am I going to need to add or subtract to find that total amount of rotation? Y'all, that is it for this video. I hope it was clear, and if you had any questions, take a moment and write those down so that we can discuss them and get you on track to being able to master working with vectors in component form. Until next time, y'all, stay fired up.